There you go.
Last poll. We'll say the proceeds will benefit athletes. That'll
Make sure he still has to go.
that will benefit our golf. The amount of golf that plays. The entire back.
Not even trying to find it.
They went to Woods.
I played it live, which I really probably should play like on that. But I guess I'm. I don't know. Those teachers that used to go like, you host not the game, or you host students at the house like Friday nights. That's weird.
It is weird, but it's fun.
Like people that stay at night and play out.
This could be an entire business.
That's
Right?
The Grill Out Chill Out Casino.
I don't know.
I don't think so.
There's so
I got it.
wrong. Everything will have the little asterisk that says Pittsburgh Robbie.
I like to let my couch at night. Well, they have like. I'm like, mid to low income.
Jeez. Wow.
Alright, Moses. Back.
This is my actually like a year's worth.
Well, you killed me. Steve probably more. But like, Rod's really good. I love him.
Dude, he's definitely I'm not sure how.
And physics. I think he's like 35 or so.
Did Rafa ever tell me?
Do I know Rafa's pretty much?
Yeah.
So
I just want to make
it's
sure.
like his brother he's talking about was like 18
It's
or
just
something.
something like that, yeah.
Yeah.
What? I miss
Like every
Rafa.
Saturday the rest of the school.
Yeah.
You still talk about it?
Yeah.
Yeah.
So that's on the left.
You're so
Like
blackjack.
coming from. It's going right.
What?
How do you know what the negatives and positives which way it is?
Oh no, we're doing it in our garage. No, you're invited. $10 or bring it down.
Is it for staff and students?
It's for everyone. Yeah, bring your kids. Just make sure they add their bring $10.
I was thinking about it in like a judgment. Rod used to, and he stopped. I don't know why he stopped.
He's busy.
Maybe just because like he does coach. No one showed up.
Oh, yeah, and he's already like practicing every day, so we don't need him to do anything else.
Well, if they like in the winter.
Is your beta has so many keep on looking back in the room? But they are. There's glitter in that. There's glitter.
Oh, they are.
They are actually cute. I mean, no, his chest.
Maybe if this gets big enough, we'll start renting. They barely we got one of the grills we can get one of those trailer grills.
Oh no,
That
that
has,
puzzle
like,
is not cute. It really
bunch of
tastes like.
slots.
How was your business started? We did a grill out and chill out. Our senior year, and we made so much money.
I didn't mean to interrupt you. No, you're stealing.
What's your idea? Grill out, chill out. What is it? Grill out, chill out.
So this grill and chill out is for profit?
No, it's for fun. That's why it's $10 for bringing it down. No, the profit's gonna be on our casino side piece. It's like all blackjack.
I need to draw them.
And like you can deal them all poker. We'll have Dan Hiker running the poker.
You gotta be a dealer.
Huh?
Smart.
Kevin Wayne will be there. He'll have his cigar stand.
Is that like
Maui Day. Maui will be there. It is Maui Day. I think we have to have people on the team. We have to go on the burger. The burgers were good.
I can see my I
We dropped so many
I went so lightly. I
My dog had 3 hot dogs and 3 cheeseburgers.
Thank
They planned to get his cheeseburger, so we just threw it. The dog threw it
you.
up.
Just like the big.
Oh,
Really? Yeah, like they're just if I see one on there that I like, usually this other one's just too.
Maybe we should just do hot dogs.
Yeah. I try to buy from Busy when I can, but it takes so long to
You take one or the other, or do you take one of them?
That's so. I was like, well, great. Now I'm going to switch to the case. Great timing. It was like I could get a $12 pack of like 6 that are weird ones. Or I could get one like flour loaves for $12. It takes 3 months to cook it.
A dish for how much? Is it best for a hot dog?
Next day shipment.
No, you gotta bring it like
One dish full of hot dogs.
we'll make it cheap.
Also, like,
How many 6
you gotta bring a
months?
salad.
6 months.
That's all.
That'll work. Yeah, that's helpful.
Should I get it right?
You know what the best part is? We should
Yeah.
bring anything.
I didn't even
Just
do
wait
it.
for all the same ones like that and I'll just start grilling. Oh, we got 4 steaks, 2 chicken breasts, a couple pieces of pork chops, and about 10 pounds of ground turkey. We'll just get a meat processor and just grind it all together.
Alright, let's start talking through this, please.
I brought 5 orders.
Yeah, you did.
I did.
Yeah.
Okay. Alright, vertical asymptote x equals 2. We didn't do any horizontal asymptotes yesterday. Glad nobody freaked out. Horizontal asymptote of y equals 1. So we get this. And then as we get going down the road a little bit, I won't tell you vertical asymptote. I'll tell you the limit goes to infinity. And so if the limit goes to infinity and you shoot up forever, what's the only thing on the graph that can make you shoot up forever? Is the vertical asymptote. So I've got to give it to you in a different way. Same with horizontal asymptote. I won't tell you horizontal asymptote at 1. I'll tell you the limit as x goes to infinity is 1. So if x goes to infinity, where are we? Like out in that field somewhere, right? And then the idea is the graph levels off and gets closer and closer to 1, like as you go this way. So just kind of preview what's coming. Math of negative 3 equals 4. So that's an actual point on the graph. The limit as x approaches negative 3 from the left. So negative 3 is 2. So I've got to come toward that point from here. And it doesn't say anything about increasing or decreasing, so you can kind of do whatever you want. Leading to that point. So this is where it's a little up to interpretation. You could come down, you could come up. Don't like circle back, because then you're making a. What'd you say? So I'm a freak on this. So a line is straight. This is not a you. A line is straight. A straight line is freaking redundant. You don't have to say that. And a curved line is impossible. Isn't a thing. Yes. So I went through this whole speech last year.
What is that?
It's a curve. It's a square.
So you did curve
Or it's a combination of curves. So I went off on this last year, and then the SAT was like a week later, and one of the questions was like, there's a straight line from point A to B. And I was like, oh my god. There's no other way a line can. Okay. As I approach negative 3 from the right, the y value needs to approach negative 1. And then there's nothing else in between negative 3 and the vertical asymptote. So your job is just to connect this to the vertical asymptote. And you have a choice. As this approaches, it's almost like a magnet. This is like a magnet repelling the graph. It's going to either force it up or force it down. And I didn't tell you which. So you could really do either one. I just picked down, I don't know why. I guess I'm a pessimistic person, but you could do either one. 4 equals 0, that's an actual dot. The limit as x goes to 4 is 2. So the rows, or the bugs, are crawling toward that point from both sides. It's going to connect to that open circle. I also know the graph has to be decreasing when x is greater than 2. So I think probably something like, no. What did I do? Can't believe I destroyed the asymptote. Not the asymptote. So something like
Maybe
that.
instead of cursing, you should just say, oh, asymptote. Why did I ever say that? That would be so late for that. Yeah. That would be so late.
Instead of being like the asymptote that swears in the class. Alright, is this okay? Yeah.
Okay, so the limit is negative 3 from the right. If you were to go up, it just stops at the asymptote at the horizontal one at 1. You said it can go both ways.
No, so okay.
No.
Yeah, no, I know. I got you. So this really should be leveled out here, right?
Yeah.
Okay. That's actually like a huge misconception that I'm glad you pointed out because now I can clear that up. There are only 2 spots where a horizontal asymptote matters. Anybody know what the 2 spots are? What are the 2 x values where the horizontal asymptote is relevant?
And this is
Yeah, they're not numbers on any graph. Infinity and negative infinity. So a horizontal asymptote just says when x is way the hell over there in the field, you need to be leveling off toward 1. And when x is way over there in the pond over here, you need to be leveling off towards 1. But you can cross it in the middle as many times as you want. So like I really could do that. The horizontal asymptote only blocks you on the very side endpoints. So you can cross a horizontal asymptote in the middle. Can you cross a vertical asymptote ever? Is that what you were getting at?
Yeah, that's exactly what
Okay. I mean, I'm guessing no one like did that graph, but there's nothing wrong with it.
Well, no, but I did a parabola that went up to it, but I didn't know if I could flip the
Okay.
other way. Okay.
You can blast right through it in the middle, just not along at the very extremes. It's like it's got weak defenses here, but on the sides it's like strong. Other questions on this? Alright, so in my opinion the work gets a little bit rougher today. We threw through like 3 lists yesterday, and I really think people had a ton of problems, or they should tell me. Today I think it will be a little slower, which is fine. So there's kind of 2 types of problems. This is the one that I'm going to guess people had more difficulty with. I'm going to change it a little bit. I'm going to say I don't even need the graph really. Let's do this problem together, but forget the plus part. We're just going to do the limit as x approaches 3. But we got a piecewise function. You want a second to like write down the problem? I want to try to leave the ones in your book for you to practice, so I'm going to do a couple separate ones. But I mean, if it comes to it, I'm happy to do the ones in your book too, but I think you guys are a little more confident in your work if you do it. Watch me do it. Let's actually do 3 things. We'll go limit as x approaches 3 from the left, limit as x approaches 3 from the right, and then limit as x approaches 3.
Yeah, so I have a couple of points. Probably like, I don't know, like the worst thing you can do is like look at openings. You shouldn't look at openings, just play games and cameras. But like
describing the graph. So to the left of 3, the graph looks like x plus 1. If I can zoom out, you can see it, but it's not that big a deal. So when I'm asked for the limit as x approaches 3 from the left is values that are smaller than 3. Smaller than 3 tells us we're using this piece. So you take the 3. I know I'm going to use 3 because they're asking me about 3, and also because that's where like the confusion lies. Like something happens at 3, obviously, right? So if I want to know 3 from the left, I'm going to plug into this one. So 3 plus 1 is 4. If they ask me for the limit as x approaches 3 from the right, well, from the right is values that are bigger than 3. So x is greater than 3, so I'm going to plug 3 into this one. So if I plug 3 into this one, 3 squared is 9, minus 2 times, so 9 minus 6 is 3, plus 1 is 4. So I've got these two roads that come together at 4. So if I asked you what's the limit as x approaches 3, what are you going to tell me? You tell me 4. Because these two were both the same. If they weren't both the same, like let's say this was 4 and this was 0, what would this be? Does not exist. Because they have to be the same for both sides, or the answer does not exist. So this is two things that come together. You got like this, and this, or something. And they both come together at that spot. So from either side, you're going towards the y value. If they didn't match, you have like this, and then you wouldn't know which one to pick, so you have to say does not exist. Is that fair enough for that one? So when most people start to get a little more freaked out in these is when there's 3 pieces. And of course, that's the AP likes to give you, right? Because they want to freak you out. So let me make up one of those. So let's say f of x equals 2x when x is less than negative 2. X squared when x is between negative 2 and 3. And 3x when x is greater than 3. So I could ask you a crap load of questions just based on that one little feature there, this one little function. So I'm going to do that. So I want the limit as x approaches negative 2 from the left. The limit as x approaches negative 2 from the right. The limit as x approaches negative 2. And f of negative 2. And then the same questions but built around 3 instead of negative 2. You guys tell me, do you want to try these first, or do you want me to do part of it first? You want to try it? Let's try it. I'll still go through them. I'll just provide some time before I do that. Actually, I don't know that first. Here's your time. the answers to A. I'll talk through it. Just put them up so that if you're done, you can check them.
Have you ever seen this before?
I guess I get what you're saying.
We're just starting on this.
Is this yesterday's stuff? Not of today's?
But I just wasn't sure if you'd seen it before and how to interpret what's inside whatever.
Oh, you were good.
I wasn't sure if it, yeah.
It's really kind of just plugging it in.
Yeah.
But it looks like way more confusing. Let me have part A right. Okay, so let me talk through them and I'll do B. So -2 from the left, you want to plug into the spot where we're smaller than -2, which is this one. So plug -2 in here, you get -4. Just to make sure you guys know what this means x is between -2 and 3. It includes the -2 because of the or equal sign. It does not include 3. Actually, I missed something there. I should have, well, I don't have to. I'll just leave it because I'll actually change the answer. Okay. -2 from the right, so I want to plug into where x is a little bit bigger than -2, which would be here. Plug in -2 there, you get 4. Because these two answers are not the same, does not exist. If these were the same, that would also go here. And then f of -2, you're looking at where the or equal sign is, because that tells you like where the actual value is. So -2 is in both these pieces, but the or equal to sign is here. So you plug -2 into this, and that's why I got 4 in this case. Coming down the pipe, we're going to ask if this function is continuous at a point. Continuous would mean all 4 of these answers are the exact same. So the roads meet, the value of the function is there, like they're all the same. So you don't have to worry about that yet, but just kind of putting things in your head. Same thing at 3, I'm going to look at, okay, to the left of 3, smaller than 3 is up here, so this one's 9. You're doing 3 squared. So this is not like -3, right? It's like to the left-hand side of 3. To the right of 3 is this one, so 3 times 3 is 9. These two are the same, so that's your overall limit. But what's f of 3 the way I wrote this? It doesn't exist, because I didn't put an or equals to sign in either one of those. So it does not exist. If I had an or equal to sign here, you plug into this one. If I had an equal to sign here, you plug into this one. But actually, if it was in either spot, you get 9, right? Is that all right? Okay. Questions I can answer before I change screen here? So the second kind of problem, I don't think is as bad as it looks. I think it can look pretty scary, but it's not. So there's kind of two things in this. There's the piecewise, which we just did, and then there's like these algebra manipulation type problems. So if you want to go in your book, I'm doing this. Is the book. If I were to do number 1 here, let's say. Maybe it's better to do. I'll start a little lower. Let's say I do number 2. Okay. So, limit as x approaches 2 applies to everything in this parentheses. So if you really wanted to get into it and write down your steps, which I wouldn't do, it would be this. You kind of like distribute the limit through. So it's the limit of this first thing minus the limit of the second thing. And then our next step is x equals 2, right? So I'm going to plug in 2 for the x's in these two spots. So like what's 2 times 2? as x approaches 2, as x approaches, okay, so this is 2, and then as x approaches 1, we are. Does that make sense? What I'm doing? If I were doing like this one here, this would be f of, so I plug 2 in, I don't really write all that down. I just plug 2 in here in my head, so what's 2 divided by 2 is 1, and then I'm looking up 1 in my chart. 6 goes on top. Plug in 2 here, so I get -2, I'm looking up -2 in my chart, I get -3. So that's -2. Is that kind of okay? I think that looks kind of scary, but it's really not as bad as. Be careful because some of the, we should do one of these. This is like a composite limit, kind of working your way. You always start inside out on these. So this is what's the limit as x approaches 3 of f of x. I'm going to start with this piece. So as x goes to 3, what is the y value approaching in this graph? Be -1, right? Then you take that -1 and you find the limit at that spot. So you're doing one thing and then you're using that answer to find the next limit. So then I'm going to go, okay, what's the limit at -1? I read up and that one's going to be. Does that make sense what I'm doing there? Just literally 1%. Yes, no. I don't care if it doesn't. Just don't. Okay. I'm doing this one just to do one more. Find the limit as x approaches 1. So as x approaches 1, I know there's no value there, but the limit is -5, so that's where it looks like we're going. Then I gotta take that -5 and apply that, so I'm going to -5. I'm going to find the limit at that spot, and that's going to be 2. Alright? Mikey, you got a question? You just switch it around. Okay. Alright, you guys start working on it. If you haven't done 1.5 yet, do 1.5 and ask me questions as you're going. We'll figure out where we're having trouble. So tomorrow I'll come in, I'll answer questions on 1.5. And we will start 1.6. Again, 1.6 is a little bit, starting to get in a little more of the real deal here. Yeah, give me 1 second. If you're like ahead of the notes, I apologize for not telling you this before, but don't worry about the squeeze there.
No. Last year, we talked about it.
Oh, okay. Cool. Yeah, what's up, Micah?
I don't know how to do that.
So do what?
I didn't really understand your explanation. No, I'm just saying, like, I personally didn't. I don't want to make everyone else go through it.
But that's like the if you're assuming that you're like the dumbest person in the class and you're the
I
only
was
one.
asking you.
Is it okay if I go through it up here? Because I'm sure you're not the only one. Like, that's why I want questions.
I'm just confused how you got 2 minus 6.
Where am I at? Number 2?
Yeah.
Too focused on your business plan?
I was just.
I'm kidding.
I didn't understand. I understood it with the graph, but I don't understand how to do it with the table.
Let me do A or B
It doesn't matter.
to start. Okay. So x is 2, right? Plug 2 in here, and that's saying, and now 2 times x is 4. So now x is 4. So I'm looking at my chart, and as x approaches 4, the limit is 2.
Oh, okay. So then, for that one, then if you plug 2, it becomes 1.
Yep. And that's where I got this.
Alright, I see.
I think I probably confused you by writing out all the crap.
Yeah.
That was easier.
Alright, I appreciate it.
Yeah.
Part A.
Yep.
So like you get to a spot where there's like I filled that circle, but there's like no limit. You just go to the actual point and fill the circle.
4A. Let me see. with x goes to -2, and the y value is 1, right? And then I find the limit as x approaches 1. Well, as x approaches 1, oh, I see what the issue is. The point doesn't matter. That's a one-sided limit, which they didn't really ask for. What is the answer? Yeah, I'm gonna say that. Yeah. So that, like, the idea is you want. I don't care about the point. I care like where it looks like we're headed. So you kind of cover that up, but it has to be headed to the same spot from both sides. And there's nothing approaching 1 from that side to match up with it. So it's going to be D. Does that help? So please